At this point, you will also have fluid buildup from the leaky blood vessels. This is called edema, and the fluid is white blood cells, as we just saw. There are some red blood cells, so some blood can leak out, and other fluids, right? This would be the serum. This is all going to be called lymph when it drains from this inflamed tissue area into the other parts of our lymphatic system, but for now this is just fluid buildup. I'm gonna, in addition to all of these, factors migrating to that site, we also have the introduction of some repair, where we have blood clotting. Blood clotting factors. And this would be thrombin to, or prothrombin to thrombin, fibrinogen, etc. These are all vitamin K based enzymes and proteins that are responsible for coagulating that blood at the area. Now, from the vascular reactions, let's go back here. So we just had all of this edema stuff is getting there, and our primary phagocytic cells, the neutrophils, have arrived on scene, so they undergo the process of phagocytosis. And remember, they are kind of these self-destruct, seek and destroy guys. They arrive on scene, they eat up everything, and they are very, very short-lived, so even at the site of injury, they can undergo self-destruction. And leave essentially a whole bunch of stuff for the macrophages to clean up. So this third step is pustulation, where the pus itself is phagocytic debris. Let's go back here. So pus, this is also technically edema. Although edema is a buildup of fluids at the area, we also have more things happening because of that phagocytic action. This is phagocytic debris. But you also have at the site more repair stuff going on, which is the introduction of platelets, which create a scab. So scab formation is happening at this point. And then following this is resolution and scar formation. This is the last step in the stage. This would be minutes later, sometimes an hour later, but this is where you have those late arrivers, the macrophages and dendritic cells that arrive on scene. It's primarily the dendritic cells that are responsible for capturing those antigens that are at that site with foreign particulate matter and also dead or damaged tissue. And once they begin the process of phagocytosis, they will turn around and hightail it over to the lymphatic system, where they can arrive at the lymph nodes and have that meetup site. You'll also have not just these large macrophages or dendritic cells arriving late term to clean up all of that phagocytic debris, but any memory B and T cells will also arrive on scene at this point. Not necessarily arrive from other areas, but any B and T cell that has memory to those same invading bacteria, they undergo this proliferation process, and then essentially they go out and come back again as a huge clonal army, and they can attack any of those invading pathogens with a high degree of specificity. And then for repair, we have now scar formation. This is reorganization of fibrous tissue, and then angiogenesis, which is healing of those blood vessels. So any of those ruptured blood vessels will get fixed at this point. So these ones we will write down. So the last step is, what are we on? Resolution and scar formation. Whereas we just created a scab is like a little band-aid. The scar is permanence, right? So we have our late arrivers, which are our phagocytic cells, which will also be antigen presenting cells, APCs, and this would be macrophages and dendritic cells. Macrophages, they do arrive. They are also tissue resident, so they're there already in the beginning, but they can arrive through the blood, and they are also antigen presenting cells and can activate our memory T cells too. So these APCs, when they come, they'll clean up, essentially, clean up crew, right? So they eliminate that phagocytic debris, and they also are involved in extracting antigens and presenting, they migrate to lymph nodes and present antigen to the lymphocytes. There are memory lymphocytes that can arrive in this later stage, and these guys are ones that have seen these organisms before, and they can mount a very specific immune response. Pathogen. And then we have repair. So there's two things that are happening for repair. We have reorganization of fibrous tissue, which is scar formation. And we have repair of blood vessels, and that's angiogenesis. And then we're done. Okay, so in continuation with this conversation about the innate immune system, now your book does oftentimes connect fever to the inflammatory response, and although it's true that fever can be a response to components that are released during the phagocytic process, it is not always interrelated, as you probably know firsthand. Fever, nonetheless, is a very important contributor to our innate immune defense system. And of course, we know this is an abnormally elevated body temperature. Our temperature is regulated by our hypothalamus. That's that region of the brain that's kind of our animal instincts region. And it's controlled by these small molecules called pyrogens. Pyrogen is just a category of molecules that can induce the elevation of your blood temperature by the thalamus. And if you remember or if you've taken AMP, then hopefully you know some of those mechanisms behind how your body regulates the temperature. Well, we're not going to cover that one here. These pyrogens can be of exogenous origin, if you remember that means, or originates from outside the body. This can be gram-negative lipopolysaccharide, which is an endotoxin, as a really active pyrogen. So if you have circulating lipopolysaccharide from a leaky gut or from an infection, then you will have an elevated fever, and the quantity of LPS in your blood can also correlate with a degree of fever elevation. This can be foreign blood that comes in, that can be a vaccine response, not from the vaccine components, but from the preservatives that might be accompanying that, or from the extra components of that vaccine that's responsible for helping induce an immune system response. Or, as mentioned, this can be of endogenous origin from factors released during the process of inflammation, specifically of phagocytosis. In any case, the benefits of fever are plenty. This would be with a low-grade fever. So if you recall back from Chapter 6 when we're talking about bacterial nutritional requirements, and we looked at those temperature scales, their growth curves essentially under different temperature conditions. If you remember those graphs, we saw that any deviation from that optimal temperature number results in a quite substantial drop in replication rate of the bacteria. So the same thing goes for your body. Most pathogens that are human pathogens replicate optimally at 37 degrees Celsius, which is about 98.6 degrees Fahrenheit. And so even a small 1 to 2 degrees Fahrenheit elevation can have a substantial impact on replication rate of bacteria. At the same time, it's detrimentally impacting the pathogen replication. It's also having some significant impact on host physiology. So we have an iron, a whole intricate network of iron regulation, including the molecule I've mentioned before, which is lactoferrin. There's a whole bunch of other molecules involved in regulating our iron availability, and those are all kicked into gear upon elevation of temperature. So temperature actually is a stimulator of those enzymes and helps sequester iron or deplete it altogether, making it less available for bacteria. Our host, or our human enzymes, we actually optimize enzyme function at about 99 degrees Fahrenheit. So our resting body temperature actually has lowered enzyme activity than optimal. This is beneficial because once we have that elevation of temperature, we have a significant boost in host metabolic activity. This can increase the metabolic activity in all of our white blood cells, those that are active, those that are becoming active, right? So it can help stimulate that immune response. These are some of the impacts of that. So everything we just talked about with the inflammatory response will be boosted, including phagocytosis, this downstream effector function of lymphocytes in our adaptive immune system. The replication rate of lymphocytes would be increased upon fever. Neutrophil chemotaxis, so neutrophil attraction to that site of injury, is boosted. And then interferons and antibodies, these are small molecules that are antiviral or antimicrobial in general, are also increased in production from both our white blood cells and from our infected cells. There is treatment for fever, but if possible, mild fevers below 101 do have some substantial benefits, so consider that next time you have or are considering treating one. But of course, talk to your physician and don't take my advice. If you are treating a risky patient or have a high fever, these should be treated immediately because they can have more substantial detrimental impacts than benefit. This is an interesting question. Again, we're not going to go over this in detail here, but we can talk about this later. Something that you should be a good one to ruminate on. An absolute treatment for syphilis involved inducing fever by deliberately infecting patients with the agent of relapsing fever. Can you provide some possible explanations behind this peculiar form of treatment, and what are the risks? So to help get you to where you can even think about this question, let's make sure you understand. First and foremost, syphilis is a sexually transmitted disease. This one that still exists in our population today, but we have treatment for it, actually quite a simple treatment, which is an antibiotic. Back before the days of antibiotics, there was no treatment for syphilis, and if left untreated, even today, this always leads to a really horrible neurodegenerative disease where essentially someone kind of goes crazy, so loses judgment and emotional control, and has a very rapid and quite horrific mental decline that always ends in death. This is what one of the crazy King Henrys had, who was the off with her head kind of thing, killed all of his wives and so on. He had syphilis, and when he was in his crazy king days, it's believed that that's when he had this pronounced syphilis infection. Always interesting how much bacteria have shaped our history. So that's syphilis, and now you got to think about what relapsing fever is. This is something we discussed in our very first case study. What do we know that has temperature or elevated temperature, then it drops down, elevated temperature, drops down? This would be malaria. So this is a true story that once upon a time, before the advent of antibiotics, that malaria was used deliberately, infected into patients with syphilis to help reduce or to actually help treat this infection. It was effective in many cases. Of course, then you're left with chronic malaria infection, but nonetheless. So think about this in terms of the inflammatory response, everything we just looked at, and the benefits of low-grade fever, which is exactly what you get with particular strains of malaria. And think about how that might help reduce an infectious agent that otherwise cannot be controlled by your immune system. And we'll come back to that.